In a carboxylic acid, make sure you can see this. Okay. In a carboxylic acid, what you do is you start by numbering the carbons in the chain. So here we've got 1, 2, 3, 4 carbons. That would be butane. Let's take off the E and add anoic acid, So this becomes butanoic acid. No, it's just oic. I don't know why I put that "an." See how wonderful I am at naming? Here we've got pentane, because we've got 1, 2, 3, 4, 5. That would mean it would be pentanoic acid. The carbon numbering begins right here with the carbonyl, 1, 2, 3, and that's why we get the 3-methyl pentanoic acid. Here we've got 1, 2, 3, 4, 5, 6, 7 carbons. That would be heptane. Take off the E, and it becomes heptanoic acid. If we again number from the carbonyl, that's 1, 2, 3, 4, 5. 5-fluoroheptanoic acid. Even though the fluoro is way down at the end of the chain, you still start from that carbonyl. Also important to note, benzoic acid hasn't changed. That is a common name that we really do use, so don't lose track of that guy. Next comes acyl chlorides. Okay. Acyl chloride, you take off the ic of the benzoic acid, or the OIC of the, or the IC, of the acid, and you're just replacing it with YL chloride. In other words, take off the E of the carbon chain. 1, 2, 3, 4 would be butane. Take off the E and add OYL chloride. I'm going to change this in here too. Let's replace the E in the chain name with OYL chloride. That's a little bit more clear. Okay. So this becomes 1, 2, 3, 4. Butane, take off the E and add OYL, butanoyl chloride. Butanoyl chloride. If you're from Kentucky, it'll say butanoyl chloride. That's how I kind of say it. This one we have 1, 2, 3, 4, 5 carbons right there. So that would be pentane. We take off the E, it's pentanoyl chloride, because there's your chloride. 1, 2, 3 is a methyl. So 3-methyl pentanoyl chloride. You can also do this with other types of alkyl halides. So right here we have a bromine instead, right? Well, I'm going to count first. 1, 2, 3, 4, 5, 6. That's hexane. Take off the E, hexanoyl bromide. Now on the second carbon, if you recall, this is what we would usually refer to as an isopropyl group. You also may hear it as a 2-methyl ethyl group, but really we usually go with isopropyl in reality. Okay, next to esters. These get a little bit more complicated. So in an ester, you have a group of carbons that are attached to the oxygen, and then you have the group of carbons that are containing the carbonyl. What we like to do is we like to name the main chain that's containing the carbonyl, and that's the root of the word, just like it was up here, right? So the main chain containing the carbonyl is the root of the word. That's where the pentane was, where we started. That's the same thing here. You begin by naming ethane, because that's where the carbonyl is. So I'm going to say ethane, but I remove the E and replace that with O8. So the O8, the E, get it? Da-dum-dum. That was bad, okay. Then you go back and name the other carbon chain that's coming off of that. So this becomes propyl because there's 1, 2, 3. That's where this propyl is. It's like a substituent group, ethanoate. Here we've got the main chain as being 1, 2, 3 carbons because that's what's contained in the carbonyl. That would be propanoate. And over here we have a cyclopenyl group. So that becomes cyclopentyl propanoate. Here we have 1, 2, 3, 4 carbons. So it will be butanoate. And the R group is now a benzyl group. So benzyl butanoate. And if you look at the conjugate bases, what we refer to as carboxylates of the carboxylic acids, these are named actually really similarly to the esters. Because now we still have propanoate, but instead of having an R group like right here, we name that sodium, because that's sort of what your R group is it's sodium. Lithium ethanoate. So those guys actually aren't too bad. Okay. Next, I want to talk about amides. My pen draw in here. Now, you again begin to name the chain with the carbonyl and replace the word with the term amide. Okay. So this is 1, 2, 3 carbons. This becomes propanamide. So propanamide. Propanamide is another way to pronounce that. 1, 2, 3, 4, 5, 6 carbons here, which would make this hexanamide. We have a methyl at the second position of that chain, so it's 2-methyl hexanamide. If you have an R group coming off of the nitrogen itself, so instead of having these hydrogens here, in this example, we have 2 R groups coming off of here. You name these R groups just as you would any other R group that's coming off of a chain. Like the 2-methyl is an R group, right? It's a substituent. The only thing is that you have to tell people where that substituent is placed. And if it's attached to a nitrogen, that is on the N. And we put the N in italics, so it's kind of, the one that's sort of slanted. So, like in this case, this is a more complicated example. We've got 1, 2, 3, 4 carbons. That means it would be butane, but there's an amide to it. So we take off the E and we add the term amide. So this becomes butanamide. Now we go back and look at what other substituents we have here. I have a methyl group here. I have another methyl group here. And here I have an ethyl group. So just as you would in any other type of naming, now you want to go through and put these in alphabetical order and tell people where they're attached. So this guy is an N-ethyl because we have an ethyl group that's attached to a nitrogen. 2, N, because we've got a methyl group in both of these positions. Dimethyl butanamide. And yes, you can mix numbers and letters. That is totally fine. Just to let you also know of a couple of very common types of cyclic structures. You could actually have lactone, which is an ester that's encircled into usually a 6-membered ring. To be a lactone it would be. And this guy we would name as 2-oxacyclohexanone. This would be 3-bromo-2-oxacyclohexanone. I'm probably not going to ask you these. These are a little bit too fancy for me. You do count, so this would be number 1, that would be number 2, and that would be number 3, which is completely opposite than most of the stuff we just looked at there, I realize. And this is what you refer to as a lactam. And this guy you would name 2-azacycloalkanone. Now, these are very important. We've used them a lot recently, looking at different types of drugs. So that's the reason why those are also very important. You may talk about those a little bit more also in like a biochemistry class type of thing. Okay, thank you very much.